but this is just telling us if it's incredibly rare opportunity, but it will happen. So I think anything can happen. So we'll see what will happen. And very rare possibility is happen. So we will.
So the newcomer to this competition can win the competition.
Yeah.
It's a small gap.
Yeah, it will happen. So now I would like to invite category 2. So we provided guidance book already, and so coordinators may opportunity to see that, but it's still quite difficult to be honest. So Professor Nakasuka will talk about it in category 2.
How many minutes can I take?
As much as you want. Yes.
Okay, so good morning, ladies and gentlemen. So I'd like to briefly overview the category 2, mission contest category 2. So this is a very new type of the category, and in this category we would like to invite more non-space related people to come into our field. Such kind of the businessman or the one who is making some space content or some image, who want to sell the image to the public and so on. And in this mission, in this category 2, the mission idea is already fixed. You can choose from remote sensing, information collecting, and rental space mission. So also you can combine not only one but also 2 or 3 missions all together into one satellite. And for example, for the remote sensing mission, maybe you can choose a ground sample distance (GSD) from several candidates, such as kind of the 2.5 meter, 10 meter, 50 meter, and 200 meters. And also you can choose several swaths of the images and so on. And create your own business plan, which is very interesting to the many potential customers, and also which will make more return than investment. So this is more a business, business plan type of the plan is required. And also you should make clear a detailed plan on how to use the equipment of the satellite, and you should evaluate. You should make optimal system configuration to maximum return. System configuration include number of the satellites, number of the ground stations, and number of ground equipment for the information collecting mission, and so on. So you can find a very good combination of the number of the satellite, number of ground station, and so on. And finally, you should calculate the amount of investment and return. We have a very rough, cost model for each system, such kind of for each ground station how much you should pay, and for each satellite how much you should pay. The satellite cost depend on the performance of the satellite. If we require very high very precise ground image, so the cost will be higher. Okay, and if we mix several missions into one satellite, of course, the cost will be higher. And if we require more ground station, of course, cost will be higher. So please make a very good trade-off between the cost and the performance. And as to the remote sensing mission, so we have several. We have to write this. Maybe we have several design criteria. So you can choose optical sensor or infrared camera, and you can select several ground resolution (GSD), and also you can choose the size of the image area, such kind of the 200 kilometer by 200 kilometers. And for the infrared cameras, you should choose temperature resolution level of infrared sensors. Okay, and this is very simple model of how much image can be downlinked per day. So a satellite can communicate with one ground station for 40 minutes. That is 2,400 seconds per day. And if you have a G, this is the number, G ground stations, the satellite can downlink for 2,400 second times G sec per day. This is very, very simple calculation. And so the number of images sent per day can be calculated as this number divided by the data size of one image. And the data size is determined by the ground resolution and the size of the images. Okay, and so this is a very, very simple calculation. So you can estimate how much images you can downlink per day using this calculation. And also the another important factor is latency. So latency means the time between the images taken and to the downlink. So this is called the latency. And the latency can be calculated as 6 hours per ground station. This is the number of the ground stations. So if we have more ground stations, so latency can be reduced. Okay? If we have only one ground stations, average latency is about 6 hours because satellite can downlink the grounds to the ground station 4 times per day. Okay, and so this is a very very simple estimation of the latency. Okay, and so the next information collecting mission. So this is very unique type of submission. So you put several ground sensors, for example, to monitor the quality of the water or the temperature or something like that on the ground. And the satellite, when the satellite flies over just that area, the ground sensors will send the data to the satellite, and the satellite collects that kind of data. And in this mission, we have also several assumptions. Okay, and the first, ground sensors within 1,000 kilometer radius circular area can communicate with the satellite when it flies over that area. And so first, define the average number of, this is M, of ground sensors within 1,000, that is a 1,000 kilometer area. For example, if the city area, many people have such kind of sensor. Maybe the number should be more than 1,000, maybe 10,000 and so on. So this is depending on your mission. And so first define how many sensors will be used within 1,000 kilometer area. Okay, and then the next question is how much data can be uplinked from each sensor. And so this is the assumption. The times allotted to one ground sensor for transmitting data to the satellite per satellite visit is calculated as 600 seconds per M by M. M is the number of the ground sensors within 1,000 kilometers. So if you have more and more sensors, so the time allotted to each sensor is very, very short. Okay, so if we have, for example, the maybe 1,000 ground sensors, then the time allotted to one sensor is 0.6 seconds, or something like that. Okay, and so there are another assumption. When there are any satellites in coordinated orbit, the revisit interval of the satellite over the ground sensor is calculated as 0.5 per N day. N means the number of the satellites. So if we have only one satellite, the satellite can fly over each area twice per day. So 0.5 day interval. Okay. So this is the assumption. And as to the design of the orbit, I will explain later. Okay, so this is a very, very basic assumption of this information collecting mission. And as to the rental mission, so you can put the customers' goods in the satellite, and which will be launched into the space, and you can charge the customer rental space cost. So this is called the rental space mission. And this is onboard fee or rental fee. And the item stored in the rental space can be photographed in space. This is optional. So if we use this option, you should add an additional cost. Okay? And for example, some of the goods of the customer is photographed with some image of the Earth or the image of the space is as a background. So you can take such kind of pictures. Okay? and the optional camera is mounted. And these images of the items and with some background image can be downlinked to the ground so that customers can purchase them. Okay, so this is the assumption. And the size of the rental space area is assumed to be from 10 to 40 square centimeter. 40 cubic centimeter. Okay. And so if we have a very small rental space area, the cost is very small. And if we have a large rental space area, the cost will be higher. Okay, and if you put the camera, you need additional cost. And it is a rule that do not deploy them into the space because it will be the debris. So all the items, all the goods to be launched into the space should be included within the satellite, not deploy them into the space. So this is the rule. Okay, and so this shows the key system element for the satellite mission. So maybe you understand that we have a satellite, and so you should design very rough performance of the satellite. So we have the several rank of the satellite, such kind of the low, medium, high, and so on. And also you should design the parameter of the, for example, the remote sensing sensor, such kind of the ground resolution and the width and size of the image and so on. And also you can define the number of the ground station and their performance. Their performance is measured as the downlink capability, such kind of several kilo BPS or several mega BPS and so on. And finally, so you should define how to launch your satellite into the space, and it requires some cost.